All right, so we've arrived at 1:30. So good afternoon, and thank you for everyone for joining us. If you haven't already done so, please take a moment to introduce yourself by putting your name, the name of your program, and expand on the role that you play within your program. If you're having any difficulties with technical stuff, feel free to send me a private message in the chat box, and I'd be happy to help you. But I will start by saying good afternoon. Thanks for joining us for our second iteration of our Virtual Training Institute. This one, as you know, will be on math. So thank you to those of you who joined us for our first session and are here to join us again today. I'm really excited to share this content with you. I think Kathleen has done a wonderful job taking what we learned from the first session and expanding in a more interactive way. So I look forward to you being a part of this with us this afternoon. Next slide, please, Kathleen. Okay, so when you got into the platform today, you might have noticed you were muted. Periodically during our message, you'll have the ability to work in both breakout rooms and potentially answer some questions. So if you need to chat at any time, you're welcome to unmute yourself or send me a message and I'm happy to unmute you. That'll be great. And additionally, I'm going to send you a link right now for a document that we'll be using within the breakout rooms, and then I will also be sharing it again later in the event that you can't seem to find this. But this will be a really helpful document as we get moving today. So as I mentioned, if you're having any technological issues, feel free to send me a chat and I'll get back to you as quickly as possible. All of our webinars are recorded, so if you're not able to look into something or you want to share with somebody else in your program at a later time, I'll send that out to everyone after each session is completed. But without further ado, we have Cathleen O'Neal here to present for us today.
All right, good afternoon, everyone. Delighted to be here with you today, and it's so exciting to see people from kind of every aspect of our programs. I see we have some tutors, teachers, administrative staff, folks from DLLR, so really excited to present today. And as Gina mentioned, today's going to be a little more interactive. We're going to be trying out some of the features of Zoom that really make this a cool meeting platform. And I'm really excited personally about trying this out just as kind of a way to test and see, what we can do to incorporate more distance education into what we offer. So I think this is a really great opportunity for us to kind of play around with it today and see, what we might use in the future with students. But as Gina said, I am the Assistant Director and the ABE Specialist for Strong City, Baltimore. I've been in my position about 5 years now, and I've had the delight to teach math for the past couple semesters. I was an English major in college, so teaching math was a little bit scary for me at first, as I imagine, many of our instructors experience. But one of the things I really hope you get out of today is that you don't have to be an expert, to help our students successfully pass this exam. So I'll just start off by kind of giving you an overview of what we're going to look at today. So I wanted to start off, we're going to look at just some very brief statistics about math outcomes in Maryland. If you joined us last week with Adora, you'll know a lot of that. A major thing we're going to do today is to, sounds a little corny, but find the fun and feel the love. So really kind of to embrace math so that we can share that with our students. I know, from my personal experience, a lot of students hate math. They come in with, total feelings that they can't accomplish anything in math. And it's really our job to make them realize that that's not true, and that they're capable of learning math and being successful. We're also going to talk briefly about the wealth of resources that are available on GED.com. Again, Adora mentioned a lot of those last week, but I think they're so useful that they're worth mentioning again. We'll briefly talk about some of the resources that are available to test takers, like the formula sheet and the calculator. We're also going to talk about some major strategies you can use for building students' math language and helping them develop in that area, so kind of learning to talk like a mathematician. And also really, kind of taking on that identity that you're not just someone doing math, you are a mathematician, and, sort of the power behind that. And we're also going to take some time to really talk about a focus on critical thinking and kind of moving away from computational skills and really focusing on higher order and critical thinking skills that are going to benefit students the most. So that's sort of our overview for today. And as I mentioned, I hope that you'll be actively participating today. We're going to have a lot of opportunities where you'll be participating in polls. I'm going to ask you a lot of questions where I hope you'll share your knowledge in our chat box. And then also we're going to try something called breakout rooms where you'll actually talk to each other. So I know a lot of times on webinars, we tend to kind of take a back seat, but I'm hoping to really involve you in this one and, just kind of embody that tenet with adult education that, though I'm the presenter today, everyone has knowledge to share, and I really hope we can learn from each other. So get ready to share your knowledge. So we will get started here quickly with just looking at some of the outcomes from Maryland. Math is one of those tests that, our students struggle with the most. That's kind of the story nationwide. But the good news that you can see from this graph is that a lot of our students who are struggling, who are not hitting that passing mark are really not far off. So you can see from here that almost 40% of the students who aren't passing are in that too close to call range. So they're just, somewhere between 1 and 9 points from passing. So to me, that's really good and encouraging news because it shows that with instruction and some of the strategies we're going to cover today, we can really get them to that passing mark and hopefully into those higher levels as well. All right, so we're going to start off with a brief poll. So I think Gina's going to get those going for us. All right, so this first one here, if you could rate your ability in math. All right, so we'll take a couple more seconds for folks to vote. All right, so I'm going to share these results with you. It looks like we have a good range here. Nobody voted in the don't ask category. And we do have some people who can take us to the moon in the audience, so that's awesome. But most of us are in this 54% range where we say, we feel like we've learned all the math on the GED exam back in high school, but we have to relearn it as we teach it. And I think that's a totally fine place to be. I can tell you from when I've been teaching math, there have definitely been times where, the night before I'm kind of cramming it in and, just reviewing that. Because as we all know, if you don't use it, you lose it. But it's good to know it's at least somewhere there. All right, so we have a few more. So the next poll, if we could start that one. Okay, so if you could, in this one, if you could rate your attitude towards math. All right, we'll take about 10 more seconds. All right, so this is pretty encouraging. We have a lot of folks, 38% who love math, yay. And about 54% of us like math. Nobody says they absolutely hate it, so that's really great. And about 8% of us said that we're ambivalent towards it, so that's encouraging. All right, we're going to try one more poll. This last one is going to ask you to rate your students' attitudes towards math. So think about, the majority of your students, if you ask them this question, how would most of them answer? Okay, so we'll close that one out. Yeah, so as I'm sure many of you predicted and as I expected, a lot of our students are going to rate as if they hate math. We're lucky if we get somebody who's kind of like, it's okay, I don't hate it. It's pretty rare to get someone who loves math, unfortunately. But I will say I was recently observing a class in our program. It's a foundations level math class, so it really works with students who are really just working on basic operations like addition, subtraction, multiplication, division. and the teacher was working on order of operations, actually. And some of the students at the end of the class said they loved it. So my heart was singing. I was so happy. I don't think they would have said that when they started, but that teacher, I want to give her a shout out, Miss Mia, has done a really awesome job really building up her students' confidence and getting them to, feel like they can do math and leading them towards, if not loving it, enjoying what they're doing. So that's really exciting. So what we're going to talk about next are just kind of some attitudes and biases towards math that we may or may not be aware of. Okay, so that's kind of our next section here. So we're going to try and find the fun and feel the love. Again, as corny as that sounds, I think it's really important. We all know from working with students that if we share a love of what we're doing and an excitement, that's infectious. So I think, even though we have some people who, they identify as being ambivalent towards math or not that great at it, if you can find something you like about it and share that with your students, it's really, really powerful. So what we're going to do briefly now is try out a feature of Zoom. I'm not sure if people have tried this before, but it's pretty cool. It's called Breakout Rooms. So basically, we're going to have the opportunity to actually talk to each other now. So when you go into a breakout room, you're going to have probably 4 or 5 other participants in the room. So you're kind of going into a separate chat room as part of our call today. So, you'll just be speaking with people in there. I have some discussion prompts that I want you to talk about, and you can also, I'm not sure if they're going to continue to display when you're in the breakout room. So if you open up the Google Doc that Gina shared, you'll be able to see them there. And I'm able to kind of join you in any of those rooms and pop in and see how things are going. We're going to do that for about 3 to 4 minutes, and you will have a 30-second warning before the room closes, and you'll be brought back to the main presentation. All right, so what I'd like you to talk about in those rooms are basically think about taking on the identity of yourself as a learner. So want you to be able to share your experience learning math, how you would categorize it and why. And if you could talk about a specific experience you've had learning math and what made it positive or negative. Was it the teacher? Was it the material? Just sort of kind of some time to talk about your feelings towards math. So we'll go into those breakout rooms now. And again, this is a good time if you want to pull up that Google Doc so you can continue to see those questions while you're in your breakout room. That would be great. All right, so I'm going to open the breakout rooms now, and basically you're going to be taken to, there will be, I don't know if anybody is willing, if you weren't able to hear each other in your rooms, if you'd be able to, if you're willing to share something in the chat box with, your thoughts on these questions. But I was hoping that, your discussions might lead you to kind of share that perhaps it was the teacher who had an impact on if your experience learning math was positive or negative. So what I wanted to share with you next is just a couple of studies that kind of, give some background on that and can kind of, give us some research towards that, that end. So I found a couple of recent studies that, there's research been done about folks' attitudes towards math and kind of the impact that it has on their understanding of subject matter and kind of, their outcomes in the subject. So positively, about 58% of Americans actually like math.
Kathleen, I think we no longer see the presentation.
Oh, okay.
Right. I was like, you have a really great imagery, so let's.
Okay, let's see it. Thanks for letting me know.
Oh, now we see Gerald Chippert's screen.
Okay.
It's okay, Gerald. Don't stress. She can take it back. Don't worry.
Okay, here we go. All right.
There we go. And then, yep.
Okay, we able to see now?
Yep. Great.
All right. Okay, well, that's kind of a thing that happens, when you try new technology, but I think it's always worth trying, even if it doesn't go great the first time. So, yeah, as I was saying, you can see a nice graphic here that gives you the results of the study that the Pew Research Center did in 2017. So I think, good news is that a lot of Americans, they surveyed American adults and who 58% of them said they actually liked math classes when they were in the K through 12 system. And of those who liked math classes, many of them liked the subject matter, and about a third, slightly less than a third, liked the way that they were taught. But we know that most of our students fall into that group who dislike math classes. And often they dislike it because they dislike the subject matter or they dislike the way they were taught. So just things for us to keep in mind, but what I really hope that we can accomplish as adult education teachers is creating an environment where we show that we like math, and that, hopefully that will be contagious to students. Okay, a couple other research studies to show. This is a graph that's showing you, though not a lot of students who were surveyed in this study enjoyed math, they did actually see a connection between math and future employment, and understanding that doing well with math would improve their career prospects. And sort of most excitingly, almost 100% of students who took this survey believed that they could succeed in math if they put the effort in. So that's pretty cool to me. They might not be willing to put the effort in, but they do believe that they could succeed in it if they tried. Oh, hold on, this one is out of the wrong order. Okay, another study, this was a 2018 study from Stanford, found that there's a link between having a positive attitudes towards your ability to do math and your performance on math problems. So this was a study done with elementary school students, but basically they found that the students who believed they were good at math performed well on math. Those who believed they weren't good at math, had outcomes that weren't as great. And I think that's something we certainly see in our students as well. This is a totally separate study from Stanford just last year. This was a study in which they designed a MOOC, or a massive online course, to specifically teach the relevancy of math, specifically teach that everyone can succeed at high levels of math, and to teach heuristics or practical problem-solving strategies like drawing or talking about math can help you learn math. So it was a course actually designed to change people's attitudes towards math. And they found that the students who completed this course actually had higher results on their math assessments afterwards. What's unfortunate is that you can't access this course. I wish that they would share it more widely. But this is basically, in line with a lot of current educational thought, which, around the growth mindset. If you have the belief that you can increase your intelligence, then you do. Okay, so what I'd love if you could do now is if you could type into the chat box if you use any specific strategies to help build a positive attitude towards math with your students and to help them increase their self-confidence in this subject. So I'm going to be quiet for a minute or two so that you can share your knowledge.
Well, that's an awful experience, Patricia. The teacher made learning math horrible and continued to call everyone stupid. Wow.
Yeah. Sure, a lot of our students have experienced a similar thing.
I think Whitney is saying what you were just saying. Encouragement, 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 attitudes.
Okay, we have Danielle shared that she shares her own experiences of learning math and what helped her get through it, so that can be a tool for her students. That's really major. Okay, peer teaching is great as well. Okay, link to real world experience, that's awesome. Okay, point out what students can do and then build on that. I think that's really, really huge. We were actually doing registration at my program this morning. We always meet with each student individually to share their results with them. And so many students come in, they're like, oh, I did so bad, right? No, of course there's things they need to work on, but there's a lot that they know. And I think that's kind of one of our major jobs as teachers, is to really let students know that they're not starting from zero. They might feel like it, but they have so much knowledge, and it's just, we're here to help them build on that. All right, we have a lot of great suggestions about real world connections, feeling comfortable with the subject matter once they feel comfortable with the teacher, lots of practice. Yes, those are all major things. Great. I love what Teresa has said about sometimes making mistakes intentionally and allowing students to catch it. That's great. Yeah, so tons of great suggestions there. Please keep them coming. I'm learning too, so this is awesome. Okay. Oh, Whitney has said the class is for mistakes. Students don't want to write on the board or give an answer out of fear of being wrong. They begin to see they do know more than they think. Yep. We have a teacher in our program, Mr. Ware. He always says, the board is your friend. So that's where a lot of learning can happen for students, because they're able to demonstrate what they know and not just get feedback from the teacher, but really get feedback and encouragement and tips from the whole class. Great. Okay, well, if you please feel free to continue adding to that discussion as we go through, but sounds like we have a lot of these skills already, so that's awesome. Right. So we all know that attitude matters, and that can have a big impact on achievement. But I do just want to briefly touch on and really put out there that we can't ignore the systems that our students encounter and that we encounter that are really failing us. So one of those is a gender bias. You know, there's unfortunately can tend to be a cultural belief that boys and men are better at math and science and women are better at reading and social studies. There's absolutely no basis for that, but it is a societal belief, and we have to acknowledge that that can affect people's performance. So there's actually a study out of Israel done, I believe it was 2015. They studied elementary school teachers' unconscious biases and how they could influence female students' academic performances and their choices in high school. So basically, you know, the impact that a teacher could have very early on in a student's educational choices, you know, how that could affect their choices into high school and college as well. So what they did is they had a blind grading test where when they had students' names that indicated their gender displayed, teachers tended to score the boys' test higher than the girls, and when the names were removed, that bias was removed as well. So it's just something for us to think about, you know, sort of cultural biases that we may have inherited that we're not even aware that we might be perpetuating in our classroom. And just to understand that, you know, that might be impacting that of course impacted our students that we work with in adult education. Okay, the other systematic failure that I would be remiss not to mention is disparities in school discipline. So many studies have been done. I think we probably all know anecdotally from experience that school discipline in terms of expulsion and suspension is not racially unbiased. It is very racially biased, where Black students are 3 to 4 times more likely than their white peers to be expelled from schools or to face multiple suspensions. And I couldn't find a nice graphic to display this, but it can be even more disparately applied to Black girls. There have been some studies done in New York and out of Boston in particular that show that Black girls are 12 times as likely to be suspended as their white peers. 12 times. I want to say that again because it is a major problem. And again, these are issues that our students have experienced. So it's really important for us to be aware of these things. And I just want to put in a quick plug. If you haven't read Push Out, The Criminalization of Black Girls in Schools by Monique Miller, I believe, I highly recommend it. It talks all about this issue and things that we can do, you know, to remediate it as best we can. So I'll hop off the soapbox now, but I think it's really important for us to know that bigger picture. It's not something that gets talked about a lot, but I think it's really important for us to consider when we're working with students. So what I want to talk about now are some resources that are available on GED.com. And again, if you were here last week with Adora, she mentioned some of these, but I think they're so useful that they're certainly worth mentioning again. So the first one I want to make sure you know about is score reports. I'm sure a lot of people use these with your students, but if you don't, I highly, highly encourage you to do so. They're great because after the student takes the GED Ready, they get a personalized score report that pulls out the specific skills that they need to work on. You can even link it to the book that the student is using. So you'll get either, you know, lessons to study or page numbers to study. And I've seen this really work for students. You know, I had some of my students use these score reports, and they've been doing the work that we're doing in the class, but they kind of use this as a personal study plan. I had one student who she really committed to working through it, and she, you know, kind of used it as a checklist, and she wrote down the dates that she did each lesson, and that led her to being successful. So, you know, if you're not having students use these yet, please do. They're a great tool. Another thing to use is performance level descriptors. These are great because they tell you what you need to teach. I think a lot of times as adult education teachers, we're overwhelmed by the amount of material we have to cover in the small amount of time that we have with students. And these performance level descriptors can be really great because they kind of zero in on the material you should cover, kind of what's going to give you the most impact for students. And an even better use of your time, you know, in terms of what to focus on are these high impact indicators. So these are the key skills assessed on the GED test that, if emphasized in instruction, can help you make a noticeable impact on student performance, because they're not just assessed in one subject area, they're typically assessed, you know, across content areas. So basically they give you more bang for your buck. I kind of call these are the money makers, okay? So these are the ones where you really want to focus on, because you're gonna see them, you know, have an impact, not just on someone's math performance, but also on their social studies, their science, etc. Okay. All right, so this is just a quick example of one of those high impact indicators. This one is about sequencing. And as you can see here, it's focused on the reasoning through language arts test. And sequencing, you know, in text, whether that's chronological order or, you know, time order, whatever it is. But this is just showing you how that particular skill kind of goes across all the content areas. So in social studies, we can see how a chronological structure affects the historical narrative or steps in a process. It's a major part of science. You know, we see that a lot in the visuals that students are asked to interpret and in reading passages that they have to encounter. And then in math, it's major. You know, the steps that you go through to complete a process, as I mentioned earlier, you know, with the order of operations. So sequencing is a really major thing to work on. And there's some really nice, you know, hints and tricks with how you can use high impact indicators available on GED.com. So if you've been able to check out the Google Doc that Gina sent earlier, all the links of, you know, the various studies and resources I'm sharing here are included there as well. All right, another really great resource I want to share with you is Tuesdays for Teachers. So these are webinars the GED testing service puts on, and they actually come up with these topics based on national performance trends. They kind of see where students are struggling nationally, and they develop resources, you know, to help educators address those areas. And what's pretty cool is that they're all available on YouTube. So if you can't actually join the live session, you're able to access them after the fact. And you'll see in that circle that I have in the corner there, you're actually able to get all of the resources. Usually they come with workbooks that have a bunch of the problems, and you know, you can see all the PowerPoint slides. So they're really good to check out. So there's a list here of all the mathematical ones that they have. There's a grab bag. They have one on inequalities, which I notice is I feel like the GED testing service loves inequality, so that's a good one to check out. Functions, which, you know, I know from working with students, that's often an area they struggle with. And I have to admit, that was the thing I was most scared about teaching, but it's really not that bad, and that webinar helped me a lot. So I encourage you to check those out if you have some time. All right, next thing we're going to talk about is using your resources. So I think we have a quick poll next. I would love to hear what resources you use with your students. All right, and I believe you're able to check all at apply, hopefully. All right, so we'll take just a few more seconds for everyone to answer the poll here. All right, so let me share these results with you. These are pretty encouraging. Looks like most of us offer explicit instruction in the formula sheet and also the calculator that's available for students. Not so much on the calculator reference sheet. And I have to admit, I do a ton with the formula sheet and the calculator itself, but I've kind of ignored the reference sheet. And I think that's to my students' detriment. It's a resource that's available for them, so we want to make sure they know how to use it. All right, so we won't spend too long on this, but I'm wondering, if you use the formula sheet or the calculator, if you'd be willing to kind of share any of your tips or tricks that you use with that in our chat box here, so that everyone can, benefit from your knowledge. But basically, formula sheet is available for students. Please make sure they know it and they know how to use it. I always tell them, yeah, this is available for you when you test, but the more you can know about it now, the better. So if you know what's what, what these letters stand for, the more it's going to help you when you actually get on the test. All right, and same situation with our calculator. So if you're not using the calculator with students, I really encourage you to use it every day. There's really only 5 questions that students cannot use the calculator on the test. So the majority of it, they can. I sometimes have students, and I'm sure you've encountered this as well, where they're like, well, I want to know how to do it, longhand. And I totally respect that. But they have a tool for a reason. So I usually tell them, it's like, well, I need to know how to drive around town in case my phone goes out, but I do have my phone to help me get around. It's a tool that's available for me. Or it's kind of like using a timer when you're baking something. Yeah, you could just like guess, how long has it been? 45 minutes? Is my bread baked? Or you could use a tool, right? So these tools are provided for a reason, and it's because they really want students to focus on the application of skills versus the computation that they need. If a student doesn't know 9 times 7, I'm not sweating it. They have a calculator, they have tools to help them do that. Of course, they're going to do better if they know their times tables, but we shouldn't really spend time drilling them on the times tables. We have to use the time that we have, which is limited, more effectively. So here on this slide,
we do have a couple from your question that you asked. What tips or tricks do you use with the formula sheet? There's a couple of responses in our chat box here.
Wonderful. Okay. So let's see what we have here. Ms. Cynthia says she uses the formula sheet every day with a warm-up. The calculator poster, yes. That's a great resource when doing simple math problems so they can see what keys we are supposed to use. That's awesome. Data button for finding M and B. I think that's related to slope and intercept. That's great too. Gerald has said New Readers Press has a great book for calculator use. Whitney has shared the table button and data button for number summary, table button for equations and functions. I'm going to have to get with you all after to learn more about this because those are sort of new to me, but that's great to hear you're using those with students. Let's see. If you have any other tips and tricks there, please feel free to throw them in. But just want to make sure that everyone is aware of the resources that are available on GED.com. That calculator reference sheet is really great, especially if you don't have access to one of those TI 30XS posters that you can actually show them the buttons to push on the calculator. That calculator reference sheet is great because it takes the skills that are really most needed for students and it shows them how to do that. And that's available for them while they're testing, but why not take the time ahead of testing and show them how to use it. All right. Okay, so what we're going to move in next is to sort of talk about the math language that students need. But before we do that, let's just look at this sample problem for the GED exam. And if you could type into the chat box skills that students need to solve this problem. Okay, and it could be anything from, the computer literacy skills they need to the mathematics skills, anything like that. Okay, we have averages from Gina, thank you. Okay, yes, Teresa said they have to be able to discern important information from just extra verbiage. Totally. Pamela has said the rate of increase, for sure. All right. Okay, which formula to use? Definitely. Great, thank you. Okay, so I have a nice little slide here from GED Testing Service that kind of gives us, some skills they need, at least from their perspective. So one of these is they need reading skills, and I think, Teresa, you mentioned this well in your comment about discerning. Oh, I'm sorry. Thank you, Patricia, for letting me know part of the question is blocked. Hopefully you can see it better now. So an increase of conceptual knowledge is also needed. That increasing at the same rate is definitely something they need to know, depending less on rote memory. And as I mentioned before, really building their math vocabulary. So I know with my students in particular, the language is something they really struggle with. So what we're going to talk about now is, some different strategies you can use to address that gap in mathematical language. But first, we're going to do another quick poll. So this one is about, students' ability to speak like a mathematician. Okay. Is the poll coming up for folks? Okay. Oh, okay, here we go. Okay, so this is a quick agree or disagree statement. If you feel like your learners have sufficient mathematical vocabulary to be successful on the GED math exam. All right, we'll take about 10 more seconds. All right, so I'm pretty surprised actually that we have 28% who say their learners do have the language necessary. That's awesome. That must mean you're doing wonderfully in your vocabulary instruction. But most people say they disagree, that students have the mathematical vocabulary they need to be successful. And I would say I disagree with this as well. This is one of the biggest gaps that I see that students really need help with. They might understand the concept of perimeter, for example. If you said the outer edge of a room, but the minute you call a perimeter, they're totally lost. So what we'll talk about next are really some strategies you can use to address that. So one thing I do in my classroom is a word wall. This, a lot of times you see this in an elementary context, but I don't think there's any reason why we can't use it in adult education. So this is, on the screen here, you see an example of a word wall from my classroom. I set mine up with Post-its, and it's basically sort of interactive so that people can move them around. And, you see in the little inset photo in the corner there that you can flip it up and you can see the definition of the word on the back. I really like doing it with Post-its or something that you can move around, because it's really great if you use this resource every day. You don't just, learn a new word, put it up there and never talk about it again. You really want to use a word wall, not just do it. So I'll actively have students use this. We'll move stuff around. We use it for games like charades or, games that we're going to model a little bit later on today. But having them move it around is really great. A lot of times you'll see them arranged alphabetically, but studies show that's actually not a very good way to do it. You want to have it grouped by concept. So like you can see on this one here, I have a lot of shapes at the top. There's a little section of measures of central tendency, but it's great if they can be moved around. But just having that visual reference is really powerful for students. I'll have some of my students, they'll grab the word, they bring it back to their desk, they have it there, they have the definition, and then, we take it back at the end of class. So it works best if you have it be interactive. So that's just a quick strategy. And if you're in a classroom where you're not there every day, if you just put this on like a piece of sticky chart paper and you roll it up, it can be pretty movable as well. Okay, so I wanted to look at this problem from the GED Testing Service. This is probably familiar to a lot of folks. This is one from the item sampler. And this was actually recently covered if you did the recent Tuesdays for Teachers where they talked about math. This was a thing that they included there. But basically this is showing you that if you took out some of that key math language, would students still be able to answer these questions? So I'd love if you could offer your perspective on this in the chat box. But I know from working with my students, sometimes taking out the words makes it easier for them. You know, they actually might be able to get it a little bit better, but you lose some of the precision. And then on the other hand, sometimes taking out the words means they really can't do it at all. So in this instance, I kind of think if you take out diameter, you know, it might actually help them understand it a little bit better. But if you lose some of the words from the actual question, they really have no idea what they're even supposed to do. Okay. All right, so here's the problem, you know, with those words not blocked out so you can see the whole thing. You know, it's like coordinate grid, for example. That's a pretty high level word that our students may or may not know. Plotting, points, diameter, right? These are so integral to the problem that if you're not sure what these words mean, you really don't even know where to go about solving it. And I think, you know, I've certainly encountered that with students. They might know, you know, if they knew diameter meant what it means, they'd be okay. But they get totally tripped up without knowing, you know, the meaning of those words. All right, we have somebody in the chat box here who has shared, see, I'm trying to scoot it over so that I don't block everyone. I saw that question on the GED test the other day. I'm surprised that removing those words may help, but it makes sense. Yeah, so I think it can kind of go either way. Sometimes removing the words helps, and other times without them, you know, you have no knowledge of even how to proceed. So it can kind of go either way. But one really great strategy that's research-based to build students' vocabulary is Frayer models. So this is just an empty Frayer model right here, but basically it's a 4-part graphic organizer to really do deep analysis of words and content-rich vocabulary. So essentially you put your vocabulary word in the middle, and you have 4 boxes where you can really delve into that word and examine it deeply. So one is a definition. And here, when you're doing this with students, it's really important to encourage them to put the definition in their own words. You know, I know my students can flip to the back of a glossary and they can write down what the official definition from the book is, but that might not help them know what the word means any better. You know, they might be still just as lost as they were when they initially saw that word. So putting in their own words is really pivotal. Another box you can use is characteristics. So that's really great just to kind of, that's a good place to kind of take some notes about the word. So you can do characteristics or sort of key points. And then really significantly are the example and the non-example box. Examples are really good. They give students a way to connect it to real world applications. A lot of times I'll have my students draw something in this box, you know, so they can make the visual connection. But just as powerfully to include are the non-examples. So a lot of times our students can think of, okay, you know, I can think of examples of that, but can I think of non-examples that are actually relevant, that aren't totally off the subject? So like if I'm talking about perimeter, a non-example might be area. You know, I'll have students do these sometimes, and the non-examples they come up with, you know, it's like, true, it's a non-example, but it really doesn't help build their understanding of it. So it does take some time when you're introducing this task to students to kind of, you know, train them how to use it, but it can be really powerful when it's, you know, when they know what they're doing. So next slide here, oh, I'm sorry, I got a little out of order here, but basically I wanted to talk about Frayer models is a really great strategy for attacking those tier 2 and tier 3 words. So tier 2 are our high utility academic vocabulary words, and those are really essential for students across the GED exams. Those could be words like inference, draw a conclusion, definition. I know when I first started teaching adult education, I was kind of surprised that students, you know, they didn't have that academic vocabulary, but so many of our students lack that. If they know that vocabulary, then they can actually answer the questions. If they don't know what the questions are asking. But Frayer models are really great also for the domain-specific vocabulary. So what we're talking about here, like this mathematical language. But here you have an example of a Frayer model. This is a Frayer model of a Frayer model, so meta. But basically, this is what we just talked about here. You know, you have your definition, characteristics, examples, and non-examples. So basically, a Frayer model, it's not a concept web, it's not a Venn diagram, it's not a T-chart, but those are great ways to build vocabulary and concept knowledge as well. But this, you know, Frayer model is kind of set up differently. But one thing I think is really great about Frayer models is that you can adjust the 4 categories. You know, so say you want to have, you really want students to draw a picture of it instead of doing characteristics, it's easy for you to make that adjustment. So quickly, we'll look at two examples. This one is for perimeter, so I'll give you a minute to look at that one. All right, so you can see, I think the non-examples on this one are really great. So they have, a kind of squiggly shape there that's not closed off. That's a really good, visual for perimeter. You can't find it because it's not closed. And lots of pictures and diagrams on here. Okay, we also have an example here for a polygon. This one doesn't have pictures, but lots of good notes here as well. So, if you have any ideas of words, sort of high utility words that you found your students struggle with, if you want to throw those in the chat box, that you can share your knowledge there, that would be great. One thing you want to keep in mind with this is that Frayer models are really good for words and concepts. It can be a struggle to fill this out if it's, kind of like a one-dimensional word or a word that's a tier 1, where it doesn't have, where someone can kind of grasp it from everyday conversation. But a lot of times when I'll do this with my students, we'll break it up. We'll pick like, 5 terms that we've been working on, and I pair students up. And, I show them this format, and it always is funny to me, whenever you give students a piece of chart paper, to me, I'm like, I want you to make it big so people can see it. And they automatically think, project. I got to spend, 3 hours on what I'm doing next. So, I have to sort of break that habit for them. But I know the first time I introduced that, that we were going to do this, I was like, okay, see what you can do in 12 minutes. And I'm like, 12 minutes? You gave us a project. So you sort of have to balance that expectation, but it is something that it's worth spending the time on because it really requires them to go in depth in examining the word and really what it means. All right, another great way to teach vocabulary. Hopefully you're doing something to explicitly teach vocabulary every day. And I think I saw someone in the chat box share earlier that they do it as a warm-up every day. But really good games to do are charades, matching games, especially if you have a word wall, you kind of already have your matching clues right there. You can do something like guessing the term with 5 clues. I really like playing heads up with my class. And that's another thing that's pretty easy for us to do with the word wall that we have. That's literally, I give everyone a Post-it note. You put it on your head so you can't see what you have, but the other students can. And you have to ask questions, and try and figure out your term. It's not only good for building math vocabulary, but also just for building the camaraderie of your class. Who doesn't love to look ridiculous with a Post-it on your head? And if you participate as the instructor as well, students really enjoy that. So I usually will put one on my head and I model it, and even if I know the word quickly, I, really try and ask a bunch of questions. So I make them, give me good answers. So what we're going to try now, you need a little piece of paper that you can doodle on. It's this game called Link Doodles, and it's courtesy of Dr. Deborah Wallstrom. So basically the way this works is that the facilitator or the teacher will call out content-related vocabulary words. And as the teacher is calling those out, the participants will doodle or draw a little visual representation of the word until the next word is called. So I always tell my students when we do this that, you might draw a circle and that's fine, but you usually have like 20 or 30 seconds to work on it. Just keep going over and over your circle because it's going to reinforce it in your brain, that that's the visual associated with that. All right, so after the initial word is called, you draw a line that connects to your next doodle, and you draw that one. You don't label as you're going. After you've made all your doodles, you go back and see, can you actually label what you've made? Can you recall the vocabulary word just from the picture that you drew? And then it's always a good practice to review your list with your group, or maybe have students share with the people around them. Sometimes they're really not able to come up with a picture, and they might have kind of a blank space, but if they can see what someone else drew, then they're like, oh, okay, yeah, that makes sense. That helps me remember it. So I would love if you would try it out with me now. So if you have a little piece of scrap paper and just a pen or a pencil that you can doodle with, I'm going to call out a few terms. And basically, I want you to see if you can make a visual representation of those words. Don't label them yet. We'll take a few seconds after we go through the list to label them. All right, so if you have your pen and pencil ready, your first word is triangle. All right, next one is hypotenuse. Equilateral. And we're going to keep it short for this example. We're going to end with Pythagorean theorem. All right, so I'd like you to take a moment now and see if you can go back and can you remember what the terms were just from what you drew? If you can go ahead and put a label on it. All right, so I don't know if anybody is willing to come on video and maybe hold up their picture, but hopefully, you were able to get something for each one, and you have some sort of visual representation. So typically when I do that with students, I'd probably have a longer list, maybe between 6 to 10 words, just so it's a little more challenging for them. But for some of those, it can be hard to draw a picture, but it really challenges them to think about the word in a different way. And for a lot of students, having that visual is really powerful. And to me, the strategy I always use and that I go to most frequently is creating a visual. But I'm always amazed with students that, a lot of them are really hesitant to do that. I'm like, nobody's going to see this picture. It's really just for you. But once you kind of get them in that mode of drawing pictures to solve problems, they really see how powerful it can be. And a lot of the GED test covers geometry. So pictures are an essential tool. But again, students don't necessarily have the habit of doing that. They don't know that that's a strategy they can use to solve them. So this game can be kind of a good low stakes way to get them in that mode. All right. So for our last portion of today, what we're going to focus on is ways that you can build students' critical thinking rather than focusing on computation. So we sort of talked about earlier how, being competently computational is great. That's certainly never going to hurt students. But in terms of what we focus on in class, it's so much more valuable for us to focus on their critical thinking and their problem-solving abilities versus their computation. So a lot of times when I'll observe classes, I see, there's a lot of focus on like long division, and that's great. I never want students not to know something, but the time we have with them is limited. Could we be focusing on word problems, for example, that require long division, where they might use a tool to help them get there? So it's really just kind of about maximizing our limited time. And we have a nice quote here from John Allen Palos, Dr. John Allen Palos, that says, "Mathematics is no more computation than literature is thinking." And I think that's really, really true. We want to get our students moving beyond that feeling that, okay, I don't know my times tables and so I can't do any math. No, it's not true. You can still think critically. You can still solve problems, and you do it every day. All right, so love to hear if you could share in the chat box problem-solving strategies that you use with your students. All right, so we don't have any responses yet. Oh, got some coming in now. All right, so from Amy, she says identify keywords in the problem. Definitely. Teresa has shared breaking the process into steps. Ooh, drawing it. Yes, Linda, for sure. That's my favorite. Drawing pictures. Diane is seconding that one. Great. Okay, yes, Joseph, for sure. Translating words into math symbols, that's major. All right, let's see, what else do we have here? Danielle has said, I have students read the question and then the choices, then read the problem, and they need to ask themselves what the question is asking them to solve. What are they looking for? Great. Karen, I think, sort of highlighted that as well. She says, focus on the question and illustrate, encourage to draw pictures. Yes. We have a great suggestion of cross out what you don't need. Definitely. There's so much extraneous information in these questions. Okay, writing down written examples, understand the problem clearly. Oh, think, pair, share. That's an awesome strategy. Yep, underlining keywords. Oh, using a KWL as you do in reading. Awesome. Yes, and I love suggestions that are cross-curricular because that's really what we have to do with students if we want them to be successful. You know, teach them that the strategies that we might learn in math class are not just useful on the math test, they're useful every test you're going to take and also in life. Pretty amazing. Cool. All right, so I hope you'll keep sending those in. But I find, you know, a lot of times as proficient students, we kind of take these strategies for granted. Our students might use them, but they might always use one, you know, and we all have one that we tend to use that works for us. But the more we can teach students what's available to them and what strategies they can use versus you have to know, you know, every single thing in this math textbook to pass this test, the better we're going to serve them, not just for this test, but really for their success in any academic context and just in life in general too. So Zathine has given us a great suggestion of hands-on activities, figuring out circumference, diameter, and radius. We use round objects and yarns. That's great. Linda has also said working backwards. Those are awesome suggestions. So what you see here are sort of the problem-solving suggestions that the GED testing service suggests we teach. So they define them as heuristics, which are practical problem-solving strategies. And a lot of those you'll see are things that people here have mentioned. So drawing a picture, working backwards, making it simpler, making a list, looking for a problem, a pattern, acting out the problem or using objects, writing an equation, using a chart or making a table, and using logical reasoning, for sure. So these are really, really powerful strategies to teach students because they allow students to focus on a strategy to solve the problem and not get hung up on all the little math details that they may or may not know. All right, so we're gonna try breakout rooms again. I think they might work a little bit better now because we'll have a longer period of time in them. But basically, what we're gonna do now is we'll go into breakout rooms and you'll have about 15 minutes to solve 3 different problems. And what I really want you to try and do is not solve the problem using the mathematical process that you may know as a mathematics instructor and an adult education teacher, but see if you can use one of those heuristics that was mentioned in the previous slide to solve it. So can you figure it out for making a table? Can you draw a picture and figure it out? Kind of want you to think like a learner and approach these problems like you may have some gaps in your knowledge, as we know our learners do. Okay, so Gina has just helpfully sent the link to those problems again. So you want to open up that Google Doc so you can see those. Again, there's 3 problems there, and we'll go into those breakout rooms now. All right. Okay, well, welcome back, everyone. Seems like we had some mixed results and mixed success with that approach. It looked like a couple breakout rooms worked really well. When I popped in, there was awesome conversation going on and good discussion. Some people looked like you maybe didn't have anybody to work with, so I'm sorry about that. But hopefully you were at least able to see the problems and maybe work through them on your own. But I really appreciate and I applaud you for giving that an attempt. I know it's a little weird, but I'm glad you tried it. So, hopefully if you weren't able to speak with someone this time, we'll be able to kind of share some feedback into our chat box. So we have just about 10 minutes left. I just want to kind of go through these problems briefly, but hopefully you had some good opportunity with, other participants, and if not, some good thoughts on your own. But was anybody able to get an answer for our M&M problem? And if so, if you want to share that in our chat box, and if you want to specifically share the strategy that you might have used. All right, I'm sure someone has an answer out there. I know for online web calls, it's good to increase your wait time. Oh, Whitney Pierce, you're getting a shout out. Cool. All right, let's see what we have here. We got 6 yellow, 30 blue, and 60 red. Okay. We wrote an equation. All right, cool. All right, so I want to show you, these are problems from GED Testing Service. Oh, you just chart and draw on the board. I love that. Thank you from Tanika. All right, and Cheryl, so let's see if everyone gets the same number. Okay, so you are correct. It's 6 yellow, 30 blue, and 60 red. So GED Testing Service has given, sort of 2 good strategies or heuristics that students could use here, one of which is making a table, as you can see on the left side of your screen, and another is writing an equation. Oh, Joseph has said a ratio problem. That's great. Yeah. Yeah, so I know that one of the major skills I work with my students is how to write equations. So, I definitely see how writing equations is a heuristic, but for my students, it's really not a practical problem-solving strategy. It's really something they have to learn. But making a table would be pretty accessible to them. So, all right, congrats on all who got that one correct. And even if not, you did a good job trying. So the next one we had was about surface area, really. Oh, Diana has said put in buckets. If you want to elaborate that on that, Diana, I'm not totally sure what you mean, but it sounds intriguing. So the next one was about painting a pillar. And, I think we can see quickly that, oh, okay, great, this is a surface area problem. And, if I was going to solve it, I'd probably go to that surface area formula. But what other strategies did people use for this one? Not necessarily using the mathematical process, but trying to use one of those heuristics. Do anyone get the answer? Okay, 15 cans of paint. I think you're correct. So how did you solve it? Okay, using that formula, great. Okay, so that's awesome. If the formula works, go for it. One thing you might notice in this slide here is that you can see, you can break up 3-dimensional shapes into 2-dimensional shapes. So really, a pillar is just a cylinder, and a cylinder is 2 circles and a rectangle. So that's really great to do with students to kind of show them the composite shapes that might make up a 3D figure. And even have them build it with paper. So if they get comfortable with the formulas for the area of a rectangle, then they can apply that in other realms. Because the formula for surface area can be kind of intimidating, but if they know just area and then it's just a matter of adding it up, that can be a little bit more approachable way to solve it. Oh, and we use Google too in a group. Okay, I like it. Okay. This is kind of going back to that problem that we looked at earlier in the presentation when we were looking at the vocabulary and kind of the impact that having gaps in mathematical language can have. Did anybody get this one? This one you had multiple choice options. So maybe you used a formula. Again, maybe you looked at those composite shapes. Maybe you drew a picture. Made a table, something like that. But Patricia has said, find the circumference by drawing a column and then find the area using the rectangle. Great. So that's, I think, applicable to the second and the third problem even. Ooh, okay. Darcel is talking about slope and a change in a y and x axis. Okay. And a math teacher in the house for sure. Great. So we just have a few minutes left, but I hope, I hope that talking to your fellow participants is helpful for you. And the reason I really wanted us to try that is because that's really a powerful thing for our students to do as well. To not look at us for the answer, but to look to each other for feedback and, to really embody that role as I'm an expert, I'm a mathematician. It's okay for me to make mistakes and then I can learn from them. But just talking about math and talking through the process is so, so powerful. Okay, this slide here is just talking again about how you can, consolidate your figures to get your surface area. And that can really help students with 3D shapes. But again, another, a challenge with those problems is that they might not know, the language that talks about the shapes. So I'll do a lot of explicit instruction in my class and a lot of just having students generate examples of, okay, this is the shape, what's a real life example of it? A cylinder is a Pringles can, it's a soup can, it's a pillar. What are all the things that we can think about that are actually these shapes? And I think that's really, really important for English language learners as well, because they might have the math skills, but they don't have the language to, recognize what those shapes are. So just want to leave you with two final thoughts. The final one, or the first one of those two final thoughts, is to keep in mind this mathematical behaviors and the overarching habits of mind from the Common Core state standards. So these are kind of like the 8 skills in the Common Core state standards, and those that have been adapted for adult education, that if students can have these habits and these skills, it really will help them throughout their mathematical education and their mathematical skills, once they leave an academic setting as well. So, things like attending to precision, persevering, that's major, major, major for students. I have so many times where I'll give students group work and, at the beginning of the semester, like, oh, well, I'll just wait for the teacher to come around and help me. No, they have to try it on their own. And I'll actually, have this as maybe a poster or something in my classroom. And so usually we'll make a habit of at the end of class kind of, reflecting on what we learned, reviewing it so we can increase retention of information, but also just taking a little bit of time to reflect on what mathematical practices did we use today? Did we use our tools? Did we model? Did we reason? Did we attend to precision? Did we think about if our answer was reasonable or not? And this language is kind of lofty, but it's powerful for students to think, oh, yeah, you know what? I did attend to precision today. Like, I made sure that decimal was in the right place, or I did use my tools strategically. I referenced that formula sheet when I wasn't sure what steps to take. So just, giving them that language can really be empowering for them. And the final thing I'll leave you with today is that it's better to solve 5 different problems, one problem 5 different ways than it is to solve 5 different problems. So the more in depth you can go with a problem, the bigger impact it's going to have for your students. We don't have to feel like we have to rush to cover every single thing that's on the exam. If you do one problem for an hour, that's going to have a major effect for students. They're going to be able to see different ways to solve it, think about it differently. And you always have that one student in the class who thinks totally differently from everybody else. Give them the opportunity to share their problem solving process. I was working with a student yesterday on inequalities, and he taught me an entirely new way to solve it. And it was different from any way I've ever learned before, but he was right. So really, knowing that we can learn from our students and that they can learn from each other is so, so powerful. And then, just taking time to work on one problem, don't worry if you don't cover a bunch. It's going to have a great impact for them. So I think we're right at 3. I want to thank you all so much for participating today. I know we had some tech challenges in there, but I really appreciate everybody rolling with it and trying it out. I think, these breakout rooms can be really powerful. So I'm doing social studies and science next week. I think we'll try them again then. So it's great if you, if you can test out your audio and your video, that would be great for next week. But again, thank you so much for participating, and I'm so excited to go through the chat. I was kind of reading as we went along, but I know there are tons of amazing ideas in there, so I hope you'll take the opportunity to do that as well. I hope to see you next week, and I hope you were able to get something useful out of today. Thank you so much.